So today I'll be talking about CI/CD pipelines using dbt, Docker, and Jenkins. So a little bit of history from us. In simple business, we've been using dbt for just over 2 years now. dbt is pretty much at the center of our mission to build a single source of truth as we expose data to systems and users across the business. Thanks to the hard work of the team, we significantly reduce the number of times where people ask the question, why is this number different? Why this data doesn't match the system? And yeah, in DNA, we believe in empowering users to own and explore their data. As our user base has been growing, we now include engineers, analysts, and finance users. So with great growth also comes great responsibility. And today I'll be talking about how we combine dbt and Docker to address challenges we faced and how our solution made it easier for users to utilize dbt. We'll also be talking about our journey with Jenkins and the problems we faced and how we implemented a solution which made our deployment process more robust. I'll also touch on what is coming down the line within simple business in terms of this project. So yeah. So a key area we identified that needed improvement was around user setup. 2 years ago, our plan was to make the installation process as easy and seamless as possible. If we now pictured the journey of a new dbt user in simple business, they would start by having to install dbt local to their machine. They also have to make sure that they have all the dependencies required to run dbt installed in their machine correctly, like Python, for example. And this process is well documented, but if you can imagine, it's sometimes daunting for someone that is not very technical to use the command line, for example, to run a bunch of scripts which they probably don't even understand what they do. And if there is a problem midway through the installation, most of the times they probably don't even know how to fix it. And even in those scenarios, if someone comes in to help, that person needs to understand, have they followed all the steps? Have they installed all the dependencies? So all this process takes time just to get the tool up and running. So we also seen situations where users were having difficulties in upgrading dbt. So for example, they didn't know if they had to use pip or brew when upgrading. And sometimes when upgrading, users didn't realize they've actually upgraded Python, for example, which in some cases wasn't compatible. The Python version wasn't compatible with dbt. So they had to go through the process of reversing that change and kind of having it in order to use the tool pretty much. As you can see here, our process can be very smooth if they follow the documentation and they know what they're doing, but it can also be a little bit bumpy. So we thought there must be a better way to make the whole process more user-friendly and the tool easier to use. So we saw on our special virtual room and we were looking for an answer, and the answer we come up with was Docker. So what is Docker? So Docker is a tool designed to make it easier to create, deploy, and run applications. An important element of Docker is images. So images are immutable files that contain all the necessary parts to run an application, such as source code, libraries, and other dependencies. And then there are containers. So containers are running instances of Docker images. So one thing to note here is that containers require images to run. So they are dependent on those images, and they use that image to construct a runtime environment to run the application. So as a reminder, so images can exist without container, but container needs an image to exist. So what are the benefits of using Docker containers? They are portable, so they are available from pretty much anywhere and can quickly be shared. They're reliable, so as the containers operate in an isolated environment, everything remains pretty much consistent between users. They are lightweight, which means they share the machine OS system and means that, for example, they use less memory. So going through our project, so our objective here was to Dockerize dbt by making use of a common image which could be shared between users and systems. We plan to make use of containers to run dbt in a reliable environment. So how did we achieve this? So we started by creating a Docker image which contains the dbt infrastructure. In this image, we install dbt and all other dependencies, such as dbt helpers, Python, and in our case, a Snowflake connector. So once we have the image pretty much packaged, we pretty much ready to publish that to AWS and be then accessed by our users.
So once an image is built and ready to be shared, we publish that to AWS. So in terms of our project, so we started by creating a dbt Docker, a dbt infrastructure, and which is an image. In this image, we install dbt and all other dependencies such as dbt helpers, Python, and Snowflake. Once we have that image bundled up, we publish that to AWS, which can be then accessed by the users. So the benefits of using a Docker image to hold the infrastructure is that as a team, we can control any future upgrades to dbt or even roll out new features when they're pretty much in a stable position, and we can test this in an isolated environment. So this slide here goes through the setup of local developments. So if we imagine the previous slide, we built our dbt infrastructure. This is available in AWS. So now let's focus on the users and how the users would work with dbt locally. So the process is very simple, as you're going to see. So the users would start by running a script called pull dbt. So this script connects to AWS and pulls down the latest infrastructure image, which then gets stored locally. So after that, after they got the latest image, they then run a start dbt script, which utilizes the same image to start a Docker container, which has dbt in the complete environment. So here the users can access the models, the macros, the seeds, and they can do pretty much what they do outside the container. So they can run the models, they can test the models, they could compile the codes, do pretty much everything they do outside. But remember, they operating in isolated environments. So what did we achieve by doing this? We now pretty much simplified our setup process. So now for a user to use dbt, all they need to do is run 2 scripts. So one script, which they do only when required to upgrade or when they first start using the tool, and the second script, which they use when they need to access dbt. So we solved the problem, right? So to summarize, we had an installation process which wasn't very user-friendly, and we solved this by condensing the installation process to a single script, which installs dbt. And then by using containers, we pretty much made dbt portable, reliable, and lightweight, which is everything that all the benefits of a Docker container. So what else? Now we managed to make dbt easier to use. We went back to our special virtual room and we started to think what else we could improve. And the thing that we decided to do was to look at our CI/CD pipeline, which runs in Jenkins. So Jenkins is an open source automation tool used to build, test, and deploy software continuously. And to give everyone a brief description of what CI/CD means. It means continuous integration and continuous deployment. Yeah, so we use Jenkins at Simple Business. So we looked at this pipeline and we decided, can we make this better? So when reviewing our pipeline, the key issue we found was that sometimes broken code was being deployed to production, even with all the checks we have in place. And some of the reasons we found this was happening was because users' tests were executed against a dev database. Also, users were only required to run tests on models they change, which meant that even if those models run successfully locally, when running with dependencies, they could still fail. So the problem of having broken code in production is that it prevents pretty much anyone else from deploying until that broken code is either fixed or reverted. So the solution, I'm sure everyone is excited to find out what the solution was. We've introduced automated tests against clone production data. So how did we achieve this? So as part of our solution, we have at the center a Python script. So this Python script, what it does, it goes through logic steps to determine first if there are changes made by the user, if the changes made by that user will work in production. So it starts by comparing all the changes made in that dev branch against the main branch using a git command called git diff. So at this point, we get pretty much all the changes within that dev branch for that user. So that's good, but not everything will be relative for our test. So what we do here is we try to condense that list to only models and seed files. And the way we do this in the filter, we include a condition which filters only for SQL and CSV files. So now, all great, we got a list of what models have changed and what seed files have changed. So they exist in a dev branch, but they don't exist in master. So we got that list, good. So all list of change files and models, once we have that, we implement some further logic to determine what models have changed by running. So here at this point, the further logic, we determine the dependencies. And if you remember here, the reason why we do this is because even if that model runs successfully, it can still fail on the dependencies. So in order to get this, we use dbt lists, which first looks at the model that you're making a change, and then we get one dependent parent and one dependency child. And at this point, you might be asking yourselves, why have we decided to do one dependency either way? And the reason for that is performance. We've tried it with multiple dependencies, and we realized that it affects performance, and one dependency works for us. While doing the test as well, one thing that we've noticed as well is that sometimes the child dependency or the child model has dependency on another parent model. And for this, we've included some further logic which checks, does that child model depend on another parent model? And if it does, it gets added to the list, and we'll use this list later on. So the next step is, based on the previous list that we get of models and dependencies, we got everything lined up. The script goes through, runs a dbt run operation that creates an empty database, which is dynamically named by the user dev branch. So in the example there, you can see if we have a git branch called demo dbt, they'll get created a clone database called clone demo dbt. So the users know where to look if they have to debug and things like that. It's pretty easy to find. So the clone database, so it first creates the clone database, which is empty, and then it looks at the list of objects that we had previously, and it uses that to create a copy from production into that database. So one thing that we've done here is that after 7 days, the clone database is automatically dropped. So there's no storage of unnecessary clones databases at this point. So we're pretty lucky in Simple Business that we're using Snowflake, which provides zero copy clone functionality out of the box. But if you guys are using another database, you can probably achieve this in a different way, maybe by having views on top of the production database. So the final steps of this test process is we use the Python script to generate a list of dbt commands, which will then be used to perform a dbt run and a dbt test against the clone database. And by doing this, we pretty much make sure that whatever they're trying to run will also work in production. So I understand I went through the steps. So putting all the script together, this is pretty much what you get. So just to recap, we first detect the changes on the development branch. We detect the model dependencies, we clone the database objects, we perform a dbt run and a dbt test, and if successful, the user is able then to deploy to production. If not, the users can also go into the clone database and kind of check the data, and try to debug that way. So what did we achieve by doing this? So less manual tests for users. Tests now run production data, which pretty much means that if they run at that point, then they should run in production without any issues. The risks of broken code is reaching production is significantly reduced at this point. So what's next? So how does the future look for us? We hope by using Docker now, we will be able to split dbt into smaller projects, which will mean that the tool will perform better and faster, and we can also tailor projects to specific departments. So if you can imagine finance, marketing, they all have their own little dbt projects, which they can look after. We also open to develop a full blue-green deployment pipeline at some point. So by having two production databases running side by side, for example, we can make deployments running even faster. Thank you very much, and I'll open the floor for questions at this point.
Awesome. Thank you so much, Ben. One for me. I was getting the impression that your organization was pretty large because I was just reasoning about why it would make sense why you'd want to solve for people getting ramped up on dbt as quickly as possible, like installing it on their computers, and it totally makes sense when you have a team of that scale. I'm curious, what were you doing before? You described the pain briefly, but I'm curious what it was like prior to completing this work. What did that look like?
Sure. So we had documentation, so pretty much a step-by-step guide on what to do once you start a simple business if you require to use dbt. And it's pretty useful. It guides you step by step, and you pretty much have to copy and paste those commands into the terminal. When it works, it's perfect and is very straightforward. The problem starts when you don't have something installed on your machine, or you have a version which is not compatible, then the errors appear. And for someone which is not very technical, like for example, we start onboarding people in finance and other departments, they just don't know what to do. So that's the reason why we're trying to simplify the process as much as we could, even though engineers can probably figure out what the code is telling them and where else to check. Most of any other folks, they just need to ask for help. And it's time consuming for everyone because they can't use the tool, and we need to figure out what they've done wrong, if they've done anything wrong.
Sounds like it makes your life a lot easier.
Solving problems.
And as someone who came from that same path of being less technical and figuring out the command line, so it's definitely something I would have appreciated. We've got another question from, actually here I'm gonna hand it over to Martina to ask it out loud. Martina, go ahead and ask your question.
Yeah, I was just wondering whether this will also work for Windows user, and if you have to do another Docker image, or how that work, or will it work?
So it should work for Docker for Windows user. At Simple Business, we're not quite there. At the moment, only Mac users are using Docker in Simple Business. It's one of the key requirements. So they need to have Docker installed and access to AWS to pull the image down. Yeah, it is possible, but it depends on your infrastructure, on your company. At Simple Business, we're not quite there, but that's the next step, especially as we're looking to onboard more people. We did ask the question. The InfoSec team went away and think about it, how they would implement this on Windows machines, but they said it's quite possible, but they have security concerns, which they're going to think on how to solve.
Thank you. Yeah, that sounds awesome though.
All right, thank you.
One last naive question, just only because this is my first time at the London meetup. How long has Simply Business been using dbt?
This was just over 2 years. So even before I joined the company, they're already using dbt. For me, I've been with the company for just over a year, almost a year and a half. I've never used dbt before, but I think the tool is amazing, especially because it empowers analysts and other users to own their own data, and which frees up times for engineers to focus on other things.